let's go on to density. Density is going to be a relationship between mass and volume. It's defined as the mass per volume for a particular substance. And also note, I have a number on top and a number on bottom. Oftentimes we can use density as a conversion factor to convert mass to volume or volume to mass. Even though mass and volume are different properties, if I know the conversion information for a given substance, I can use it. So one of the things that is true is that density is always the same for a given substance at a given temperature. So I can use that information. And I can also use it to identify a pure substance. Because different substances have different densities, if I can measure the density, I can try and track it back to which substance would have had that same density and use it as an identification method. Note that it is important to know that density will change with temperature, and density changes for different substances. So you can't use the same density. So you have to know the density of the material that you're working with to actually do these kinds of conversions. So pay attention. I wouldn't expect you to memorize densities, but I would expect you to be able to look up densities on a reference table that's not directly in the problem. So be paying attention for that. Okay, so I can do density problems two ways. I can use the equation, right? Any two things I give you, you solve for the other one. So if I give you density and volume, you put them in and solve for mass. If I give you mass and volume, you solve for density. If I give you density and mass, you solve for volume. So that's an algebraic way. And this is not hard algebra. Another way that people can be successful is to, if the density is given, so if it asks me to find density, I have to use the equation. I don't have an option. But if I give you the density, I can use it as a conversion factor. So if I give you the density and the mass, I'm starting with mass, so I'm going to write the density in a format with the grams on the bottom. I'm going to flip the density and put the grams on the bottom and the milliliters on the top. Or I can go with the milliliters and I multiply by grams over milliliters. I'm multiplying by the densities and I get the mass. So I'm going to use my starting units, whatever I'm trying to convert, the thing that's not the density, to help me decide which version of the density conversion factor I'm going to use. So this is very successful for a lot of people who struggle with math, who get a little confused on the algebra. For people who are good at math, this is usually faster and easier. Both work. They get you the same answer. Just know that if I ask for density, you have to use the equation. So you're going to have to memorize this equation. So here's a couple of examples. A certain mineral has a mass of 17.8 grams and a volume of 2.35 cubic centimeters. What is the density of this mineral? Because it's asking for density, I have no conversion factor, so I have to use the formula. Density is mass over volume. Now I have to look, well, it even says mass of 17.8 grams. But if it didn't declare that this was the mass, I would know it's the mass because of the units. Grams are units of mass. And a volume of 2.35 cubic centimeters. So I'm saying this is a volume. I put the numbers in, I divide them, notice that my final units will be grams per cubic centimeter. Sometimes they're also grams per milliliter. And then I want to round it to my proper significance. Since these both have 3 sig figs, I would round it to 3 sig figs. What is the mass of a 49.6 milliliter sample of a liquid which has a density of 0.85 grams per milliliter? Note that I have a couple of different strategies here. One, density is equal to mass over volume. I'm going to put in that I know the density over here. I don't know the mass. I know the volume. And now I have to do a little bit of conversion. I need to multiply both sides by 49.6 to get rid of the on this side and isolate mass. And I get 42.16, which rounds to 42 for proper significance. Or I can recognize that this is conversion factor information because it's got 2 different properties with a per. So I start with the other one, the 49.6 milliliters. That means I need milliliters on the bottom, grams on the top. 0.85 goes with the grams, so I put that on the top. Complete the conversion, round it. I want you to practice this one. How much should a 1.5 cubic centimeter gold ring weigh? And I want you're going to have to look up a value to complete this. There's only one number. You're going to need another number. You're going to have to figure out which one it is and what to find.